Well, in this video I'm going to describe the procedure, the methodology of Iterated Greedy. This algorithm has mainly two stages: the greedy constructor and the random destruction. Although there are different variants of this algorithm, the destruction might not be random, the construction might not be pure greedy, and so on. I will skip the optional local search in the middle, although it is often applied within Iterated Greedy. Well, I'm using the same instance. So at the beginning, let's suppose that your solution is empty, and you construct that solution with a pure greedy. So the first city has been chosen randomly. This is A, the closest city is B, afterwards C, F, G, J, and so on. And you know that in this case, almost at the end, and this is the solution that has been constructed, and finally the solution produced is this one. Well, so now we will move to destruction. In this case, let's suppose that we remove different elements or chunks in the solution. For instance, C, J, K, H, E, D, and MP. Well, I have removed these chunks with a specific purpose because I want to produce a better solution, but you have to recall that the destruction is supposed to be random. So, well, perhaps by chance these chunks are removed or they are not. In any case, if the new solution is not better, perhaps in a following iteration, in a later iteration, these chunks are removed. So if these chunks are removed, then we are eliminating or removing these arcs from B to C, from C to F, from G to J, from D to M, from M to N, from P to O. And these chunks become alternatives when reconstructing the solution. In addition, since we are dealing with the symmetric traveling salesman problem, we can go one arc, we can traverse one arc from A to B or from B to A with the same cost. So we could exploit that fact and consider also moving along the chunks in the opposite direction. That means either J, K, H, E, D or D, A, H, K, J. So now the solution is this way. And we call the greedy reconstructor to reconstruct this solution. So for this first position, we have these alternatives. If we evaluate each of these alternatives, even these ones, in this case, we would move these elements one step or several steps to the right to place the alternatives here. If we evaluated the different alternatives, for instance, if we evaluated placing the alternative C here, we are including these two arcs in the solution. But for instance, if we evaluated including MP here, we are including these two arcs. Where you can see that the arcs in red are better than the arcs in orange. So if we evaluated the different alternatives, we would observe that the best option is including C in this position. C in this position. So we will have included these two arcs. For the following, for the next place where we have to make a decision, G, well, we evaluate the different alternatives. This is not an alternative anymore. So for instance, if we evaluated this, the first one, J, K, H, E, D, then we are including the arcs from G to J, and from G to M. So these two arcs in red. If we included the chunk but in the opposite direction, we will have included the arcs from G to D and from J to M. Well, in this case, you can observe that the arcs in orange are better than the arcs in red. I mean, the sum of the cost of the arcs in red is greater than the sum of the cost of the arcs in orange. And well, you should also consider these options, but in this case, you can observe that the arcs are larger. So finally, the option that you would choose according to this greedy method is precisely this one, D, E, H, K, J. So this arc, these two arcs. Well, and you can notice that we are improving the previous solution, because in the previous one, in the previous case, we got here a loop which is worse than this one. So we are in a good direction to improve the solution. Well, finally, in this reconstruction stage, we have to consider to write here MP or PM. If we wrote MP here, then we are including these two arcs, and if we wrote PM, the arcs are these ones, which are worse. So finally we opt for NP. And we have constructed the solution completely. So now we will move to once again to destruction. Well, in this case, let's suppose that we remove the elements and the chunk POLI and Q. So now the solution, the partial solution, is this one. The options are M, P, O, L, I, or I, L, O, P, and Q. Well, so let's reconstruct the solution. Let's suppose that we select the places randomly, not always from left to right. So now the first position I'm selecting for deciding which solution component or which solution chunk right is from the last part of the solution. So here the possibilities are, for instance, N. In this case, you can observe that we are introducing a large arc, and we should connect to the other chunks in the solution. But this arc is going to make that option not quite a not very good option. Another option is to introduce here Q, which also produces a very large arc. ILOP is not good either, but the one which is the best one is POLI. Because this option introduces just, well, this short arc. So in this case, the greedy constructor would choose this option, and this is not an option anymore, not this one nor this one, and we have introduced this arc from I to A. Well, now let's suppose that we would like to write a component for this place. Here we are evaluating N and Q. between these two options n is the best one, so we write here n, and finally the last one is q. So, well, in this case we will have produced the optimal solution. Obviously, I have not made random decisions. It was supposed that the destruction was random, but well, I meant this video to be instructive, so I have guided the distractions to forcing these decisions, these specific situations appear. So to let you know that the optimal solution could be produced with these operations. Well, I hope that this video helps you understanding the iterated greedy. See you.